These are the solutions for the Chapter 2 Standards Assessment, similar to what you're going to see on the benchmark number 1, or the first trimester final exam. So let's see what it says. Here it talks about a clockwise rotation of 90 degrees is equivalent to a counterclockwise rotation of how many degrees? Well, let's take a look at it. So here's our x and y axes, and if I start right here and I rotate clockwise 90 degrees, that would end up putting me right in this location here. So that would be a 90-degree turn clockwise. So if I was to go counterclockwise, it's clockwise again, counterclockwise, I'd have to go around 1, 2, 3. I'd have to go three quadrants, and that would be 270 degrees counterclockwise. So that's the answer for number 1. And moving on to number 2, it says the formula K equals C plus 273 converts temperature from Celsius to Kelvin. Which of the following formulas is not correct? So all we have to do is just modify this formula and see if we can get these. So yes, I see number 1 is okay, because notice what they did there. They have K equals C plus 273.15, and they just subtracted the C. So think about just opposite operations, and whenever you move something to the other side, it just switches signs, and that's all. So you can see definitely I can do this, so that's fine. This next one, well, what they did here is they have negative 273, so they must have brought this over and then moved the C over, and then looks like they brought the K over. So let's see what we could end up doing here. So we'll start with this, and I'm going to get the C back to the other side. So if I bring it to the other side, I've got K minus C equals 273.15. So from there, let's go ahead and move the K back. So if I move the K back over here, it changes sign. So now it's negative C equals negative K plus 273.15. So from that point, we have all the same numbers in the same spot and the variables in the same spot, but we don't have the right signs. So what we can do is multiply by negative 1, and that will switch all of those signs. It'll make the C positive, it'll make the K positive, and it'll make the negative 273. So that's okay also. Next one here, C minus K equals negative 273. So you saw how we had to multiply by negative 1. It looks like we might have to do that on this one as well. So we'll bring the C over, and we'll just keep that C over on that one side. So when I bring the C over, it switches signs. So it becomes negative C, and then it's still a positive K equals 273.15. So I'm just using this formula, move the C over, and just switch signs. So now, if I multiply everything by a negative 1, everything will switch signs again. So you see how all the signs switch, and it does match up. So it looks like D is going to be our answer. Let's just check. So we need to move the K to the right and the C to the left. Okay, when we do that, it'll switch signs again. So C becomes negative, the K will become negative, and the 273 stays as positive. So all I did is just move the K back to this side, and that's when I subtracted. That's why I have a minus sign here. I moved the C to the left, and that's why I had to subtract in order to get that, and that's why it's negative. Now, I go ahead and multiply by a negative 1 because I want to make the C's and the K's positive, but look what happens. It changes the signs of the C and the K correctly, but the 273 becomes negative. So definitely this is not the answer. So Joe wants to solve the equation. What should he do first? Distribute. Distribute that negative 3 over the x and the 2. Let's look for that one. Multiply each side by, no, don't want to multiply each side by negative 3. Oh, another way we could end up doing it. Don't want to subtract 2, don't want to add 3, so those are definitely wrong. I was going to go with this one, but this says multiply each side. Don't want to multiply each side. I wanted to multiply the x plus 2 by that, so let's switch that idea. Let's go ahead and erase that part, because none of those end up matching. But there's one that could be fine, and the one that could end up working is this. We could divide by negative 3, and if I did that, I'd want to do it to both sides, and that would cancel out that coefficient in front of the x plus 2. So I'm going to go with letter I in this case. Number 4 says, which transformation turns a figure? Well, a turn is just a rotation, so that wasn't so bad. Let's move on to number 5, and here we have a triangle is graphed with in the coordinate plane below. And so it says, translate the triangle 3 units right, 2 units down. So 3 right, 1, 2, 3, 1, 2, 3, and 2 down, 1, 2. So we put a point there, and that's going to be C prime. And then I have B prime, 3 spaces right, so 1, 2, 3, and 2 spaces down, 1, 2. So there is B prime. And A prime, 3 spaces right, 2 spaces down. And oops, I didn't go quite 2 spaces down, so let's fix that. So it looks like 2 spaces down is going to be end up right there. So that's what we end up seeing. So it should look exactly the same. So it should be the same figure, just in a different location. So let's find the one that matches. A looks to be 1 space over, 2 spaces up. This one matches. 1, -1 for B prime. 3, -1 for C prime. That's it. So let's take a look at the next one. It says Dale solved the equation in the box showing. What should Dale do to correct the error that he made? Well, let's see what he did here. So it looks like he subtracted 2/5. That's what this minus 2/5 is for. He did that to both sides. That's fine. He ended up coming up with a common denominator multiplied by 3/3. So this would be a 6. So -7 take away 6, yes, -13. That's all good. So right here I see a problem. See, he multiplied by 3. That canceled out the 3, but it kept this x term negative. He should have multiplied by a -3, and that would cancel out the negative signs here. So the answer should be a positive 2 3/5 rather than that negative. So multiply each side by a -3 to get 2 3/5. Yes, that's it right there. So notice how they said multiply each side by -3 to get this. Now that would not be correct. So there was some distractors in there to kind of fool you. So let's move on to the next one. And it is here, number 7. Jenny dilates the rectangle below using a scale factor of 1/2. And so 1/2 means that it's going to get smaller. It's a reduction in size. So what is the area of the dilated rectangle in square inches? So if we dilate by 1/2, that means you're basically multiplying each side by a 1/2, or dividing by 2. So it becomes something that looks like this, 3 inches by 5 inches. So area, well, area is just base times height, and so I'm just multiplying the 3 by the 5, and that gives me 15 inches squared. Make sure you put those square inches. I see a lot of papers that don't have those units correct. So area, square inches. Moving on to number 8. And it ends up telling us that the vertices of a rectangle are, and then they give us these vertices. If the rectangle is dilated by a scale factor of 3, what will the coordinate of C be? So let's pull C out here. And so C is 3, -5. So if we dilate with the scale factor of 3, basically we're taking that 3 and multiplying it by 3. We're taking the -5 and we're multiplying it by 3, and that gives us 9, -15 in this case here. So let's look for that one. 9, -15 right there. So it says that in the figures, triangle EFG, so EF to G, is a dilation of HIJ. And so notice when they do that, they should be telling us in order which points or which vertices are corresponding. So E should correspond to H, F to I, G to J. Okay, that's going to be important for this problem, so let's see what it says. Which proportion is not necessarily correct for the triangle EFG and HIJ? So let's take a look at it. EF, so basically when we set up these proportions, we're looking for sides that correspond in the same spot. So EF to FG. Okay, so they're using the same triangle, that's fine. So if they do that, that means we have to do this one to this one. So they did EF, FG. So then they should use this one to start with. So HI and IJ. So this is correct. This is good. And so let's try another one. I'll do a different color here. So then they'd go EG. So E to G. So they did this one right here. And then they did HI. HI. Okay. HI right here. Oh, this is a problem right now, because now they're not using corresponding sides. So let's just check the other ones. This one is suspect. FG, real quick, and they did to IJ. That would be okay, but they did this one wrong, so B is going to end up being the answer. But let's move on to just to check the other ones, just to see what we see here. GE, so I have that one. EF, okay, so they're using those two right there. And then they did JH, and that's a good, because you see they started with EG or GE, and then they did JH on the top of that second fraction, those correspond. So they should be using this one, and they do, HI. Notice how HI is right there. So that is good. EF, do this in a different color. So we have EF, so this one right here, and they're comparing it to HI. HI, see, those are in the same location, so that's good. GE, so GE is on this side, and they're comparing that one to JH. JH, and those are good too. So you can see how this one, they did not use the corresponding sides in the same fraction, so did not work out in that case. Let's take a look at another problem. So we're on to this page, and it says that in the figure below, rectangle EFGH is a dilation of IJKL. So they're saying, what is X? Hey, since we've got a dilation, that means they're going to end up being similar figures. And so I can set up a proportion to solve. So I'm going to do A is to X as 12 is to 21. So notice how A and X correspond, or in the same rectangle at least, and 12 corresponds to 8, but they're in the same location of the fraction. X and 21, same location in the fraction. So I'm going to go ahead and reduce the fraction first. I'm going to take out a common factor, take out a 3, and that makes this 4, and take out a 3, and that makes this 7. Then I cross multiply, 7 times 8, so 7 times 8, and then equals X times 4. So X times 4. So I end up with 56 equals 4X. When I divide by the 4, I end up getting 14 as the value of X. Let's see if we can find it. Right there, F is the answer. Now, in the next one, it says, several transformations are used to create the pattern. Now, describe the transformation of triangle GLM. Let's look for that. GLM right here. And then I need to transform it to DGH. DGH. Okay, so it looks like all they did is they moved it up. I don't know how many spaces, but they definitely translate up. And that's what they ended up doing there. And here it says, describe the transformation of triangle ALQ. So oh, that's a big one. AL to Q, that's the whole thing right in here. We're describing that with respect to GLM. Let's find GLM right here. So it's a small one. Okay, so it looks like that is a dilation. A dilation, but I can be more specific. It's definitely a dilation, and it's a reduction in size. A reduction. So let's see what they ask for next. It says triangle DFN. Okay, this one right here, this white one, right in the center here, and we're comparing it to GHM. GHM. Okay, right there. So I definitely see it goes from a big one to a small one. And they're asking, well, what is the scale factor? Okay, scale factor. Whenever it's a reduction, that tells me that the scale factor is a fraction. So it's always going to be a fraction when I've got a reduction. An enlargement, obviously, would not be a fraction. It would be a number bigger than 1. So when I look at it, if I go ahead and just look at like pieces here, I see that this one here has, it looks like it would fit perfectly right inside here. And then I might be able to fit another one perfectly inside here, and then probably cut it in half as well. So as I look at this one, it appears to have a reduction of probably about, looks like it might end up, this side probably doubles in size. And if I'll go ahead and look at the size here. So again, it goes from DFN is the dilation of. Okay, let me reread that again. So it says DFN is the dilation of. So actually we are going to end up, instead of going from this to this would be a reduction. So let's go from DFN to GHM would end up being a reduction. But it says that DFN is the dilation of. So of tells us that it's after this one here. So we actually have to start at GHM and we go to DFN. And so this is going to end up being an enlargement. And so if I have an enlargement, that tells me that the scale factor is larger than 1, is greater than 1. So when I look at it, look at the sides. So look at this side right here, and I think I might change color there just to make it a little bit easier to see. So notice how this side right there would fit perfectly right about there, okay, to this point. Well, it would take one more of those exactly the same size. So this is like one size, and this is like two sizes. So this scale factor would be 2 to 1, or just 2. So let's move on to the next one, and it's this last one here. And so it says that a rectangle is graphed the coordinate plane below, and we're supposed to rotate the triangle, I think it's a rectangle there, 180 degrees about the origin. What is the image? And so if I was to rotate 180 degrees about the origin, that means I'm holding this down and just rotating the entire item. So the y-axis here is going to go all the way down here. And so that means that this side right here is going to end up fitting right about here. So let's see here. We are one space over, one space up. So it's going to end up being right there, and that's going to be M prime. And then L is going to end up being one space over and 3 spaces up, so do the exact opposite. One space left, 3 spaces down. So notice how it switches one, that's 90 degrees, and then one more quadrant makes it 180. So J is over here, so that's 90, 180 would make it go over here. So that's 4 spaces right there. And J, let's see, that is actually J right there. And K is going to end up being right there. So it's J and K. And this was L. So there we have it. So let's go ahead and see what those are. So I'm going to go ahead and fill that in. Looks like M prime is -1, -1 right here. That's it. So L, let's just check the others. -1, -3, yes, that matches. K, 4, -3, yes, and 4, -1 for J. So A was the answer. Those are the problems that you'll see on that lesson.